Alright, so we're going to start section 8.5, and in this section we are going to be learning to solve polynomial equations using factoring. So the first thing that we need to do is talk about what a polynomial function looks like. And so a polynomial function is simply just a function with a polynomial in it. So we have a polynomial, remember, being some constant times x to some power, and then plus another constant times x to one less power, plus a constant times x to one less power, and so on and so forth, down to plus just a constant, or some variation of that. And that is a polynomial function. In the general form, we usually see as p of x. And so now the next thing that we're going to do is we're going to talk about a special case of a polynomial function called a quadratic equation, or a second degree polynomial equation. And we're going to be setting these second degree equations, or they'll be higher degrees, we can just use polynomial functions too, set them equal to 0, which is called their standard form, or possibly the general form, depending upon who's saying that. So our general form or standard form will look like ax squared plus bx plus sub c is equal to 0. And we have a, b, and c being real numbers, and the only stipulation being that a can't be equal to 0 because we can't get rid of that squared variable. So now, once we have that, we need to just practice putting in standard form, putting in this ax squared plus bx plus c. So let's take a look at a couple of examples here. So we have x squared minus 2x is equal to 5. Well, to put it in the standard form, what we need is this 5 to go over here, because that'll make 0 on this side. So we're going to use our addition property of equality in order to move it to that side. Now remember, you can't combine unlike terms, so this is where we're using that idea of vertical stacking to add polynomials so that we don't add unlike terms. And so there we go. We have x squared minus 2x minus 5 is equal to 0, and this is what we call our standard form of a polynomial function, or of a quadratic equation is another way we can name that. Now on the second one here, we have a couple of things to do in order to get this in standard form. Now standard form, we like the x squareds to be positive, so this time around I'm going to move everything over to the right side. So I'll subtract the 2x here in the middle, and then minus 5 here, and minus 5 here, and now this whole side equals 0, and that's equal to x squared minus 2x, and then negative 2 and negative 5, which is negative 7. And now again we have the standard form. Now I've added in another example for our lecture on online only, and this is the example that I've added in. In this one, what we need to do in order to get it to standard or general form is we have to expand this side out and then contract it all to one side. So we're going to expand by multiplying x squared, and we have a negative 3 and a positive 4, so that'll make a positive x, and then negative 3 times negative 4, which is negative 12, is equal to 2x squared minus 15. Now the x squared is larger on this side than it is on this side, so I'm going to take everything over to the right hand side. So I'm going to add a negative 2x squared, or excuse me, negative x squared to the 2x squared on the right, and then add a negative x to the right as well, and then add a positive 12 to the right as well. So now what we'll have is we will have 0 on this side, right, because all of these are 0, so we'll put a 0 over here so we maintain our equation. We don't want to ruin that. And 2x squared minus x squared, which will give me an x squared, minus an x, and then minus, and 15 minus 12, which will be a 3. And so that'll be our final equation. Now the next thing that we're going to learn is we're going to learn how to solve these quadratics after they're in this standard form. And so that's going to use something called the zero factor property. And the zero factor property, long and short, says that if a and b are polynomials, and a is equal to 0 and b is equal to 0, or b is equal to 0, then a times b will equal 0. And that's according to the multiplicative property of 0, right? 0 times anything is indeed 0. And it doesn't matter which is 0, one or the other. So what that means to us is we're going to find where polynomials are equal to 0. So I'm going to step you through this, and then I'm going to show you how to solve a polynomial equation using that. So in the next video, we'll start right here with finding values that make the a's and b's 0.